Hi everyone. Today lesson we're going to go over the solution of lateral equations and the system map simultaneous equation as well. Now let's revise of how to solve a quadratic equation and a cubic one. General form ax squared plus bx plus c. This is for a quadratic equation, right? If you can factorize, then please go ahead and do it. That's one way to do it. Factorize and apply no factor law. Okay. If you can factorize, then you just use the quadratic formula, which is x equal negative b plus minus root b squared minus 4ac over 2a. Now, this is to solve for quadratic equation. If you want to solve for cubic equation, so the general form, let's say general form for cubic is ax cubed plus bx squared plus cx plus d equals 0. Now, if you can factorize, if you can take out the highest common factor, take out the highest common factor, which is HCF, common factor, HCF, then please go ahead and factorize that. Okay. If you can't factorize it, then unfortunately, we don't have a formula. All right. Now, if d equals 0, then you can take out the common factor out. But if d not equal 0, then you have to apply the rational root theorem. So use rational root theorem. Okay. Which, if you watch previous video, we learned about how to apply the rational root theorem. So we find a factor of d, and then we use division and stuff. Now we're going to go over example of how to do those questions. Example A, so you can see I solve, this is a square, which is a quadratic equation, and I want to solve, and I can't factorize here. So I just use the formula x equal negative b plus minus root b squared minus 4ac over 2a, like that. B is a equal 1, b is k, and c k. So I apply that as negative b is negative k plus minus root b squared is k squared minus 4 times 1 times k. And then over 2a, 2a equal 1, which you get negative k plus minus k squared minus 4k, okay, over 2. And you can leave the answer like that. Now, for B, you can see here is a cubic one. I didn't have any constant here, did I? So I can take out the highest common factor, which is x. And then inside I have x squared minus 3ax plus 2a squared equals 0. Then I can apply no factor law, or I can continue factorize this further from here. So something times something give me 2a squared, and something plus something give me negative 3a. So time together equal 2a squared. I could have 2a and 1a, right? And to be add together in negative 3, I could have both minus. So negative 2a and negative 1a. So this one I can write that as x minus 2a, x minus 1a, and I have x in the front equals 0. Then from here I can apply no factor law, x equals 0, x equal 2a, or x equal 1a. And the last example, say x squared minus a equals 0. Now here they already factorized for you, so you can just apply no factor law. So you get x equals 0 or x squared minus a equals 0. So if x squared minus a equals 0, x squared equals a, then you get rid of the square by the square root the other side. and you have plus and minus in the front of the square root. Okay. Now we're going to solve for this type of equation. So in this question, you can see in all of these questions, x is in one place like that. Okay, so we don't need to factorize if x is just in one position of the equation. The strategy that we use it here is we just move everything over and solve for x. Make x the subject. So let's start with a. So I have ax cubed minus b equals c. Then I move the b over. I have ax cubed equal c plus b. Then I get rid of the a. I divide by a on the other side. So c plus b divided by a. Then opposite of cube is cube rooted. So cube root of a plus c by like that. Okay. Now if I do C, you can see here x4, question C, x4 equals C. Now to get rid of the 4, I 4 root the other side. But when you 4 root, you always have two answers in the front, plus and minus. So 4 root plus minus root 4 root of C. Whereas this one, when you cube root, you only have one answer. But 4 root is two answers. So any even number, root it, two answer. Odd number, one answer. Right? If I do D, as you can see, D here. Let's do D here. D, my equation is ax to the power 1/5 equal b. So first of all, I remove the a over. X to the power 1/5 equal b over a. Then opposite of power 1/5 is you actually power 5 on both sides. Or you can think of something like that. X to the power 1/5 is 5th root of x equal b over a. And together of 5th root, you do the opposite, you power 5. So what you do, you power 5 on both sides, like that. 5th root and power 5, they will go away. So you left with x equal b5 over a5. Okay. All right. Now, to find the intersections between two curves, we basically solving simultaneous equation. So here they find the corners of intersection between a parabola and a linear. So you can see that both have y equal. So what we do, we just let them equal each other. So we have x squared minus 2x minus 2 equal x plus 4. Then we move everything over. So x squared minus 2x minus 2 minus x minus 4 equals 0. We collect like term, x squared minus 3x minus 6 equals 0. Okay, then you try to factorize and you can't do that. So you can either commit the square or use a formula. I just use a formula here. So negative b plus minus root b squared minus 4ac over 2a. So negative b is negative 3, so 3 plus minus b squared. Negative 3 squared give me 9 minus 4 times 1 times negative 6 over 2 times a equal 1. So you have 3 plus minus negative 4 and negative 6 is 24. 9 plus 24 is 33 over 2. And you can't simplify root 33. So you can leave your answer like that. Okay, then you find the y value when you finish. So it's substitute in either of these equations. The linear is easier to do. So I have y is x plus 4, and you're going to do one at a time. So you have two solutions here. You're going to do 3 plus root 23 over 2 for x plus 4, or you can do y equal 3 minus root 23 over 2 minus 4. Okay, then you can make them the same denominator. So times by 2 here, so you get 8. So make it over 1 times 2 times 2. So 4 times 2 is 8. 8 plus 3 is 11. 11 plus root 33 over 2. Or make it over 1 here, times 2 times 2. So 3 minus 8. Sorry, that's possible here. 3 plus 8 is 11 minus root 23, 33 over 2. So you have to, when you write the point intersection, you have two answers. You either have 3 plus root 33 over 2. That's the x value, and this is the y value, 11 plus root 33 over 2. Or you write as the other solution, 3 minus root 33 over 2, and 11 minus root 33 over 2, like that. Here is a few more examples of finding the intersection. With this one, find the intersection between a circle and a line. So what you can do is you can make y the subject, and then you can sub back in. So x minus y equals 0, you get y equal x or x equal y. Okay, so you can substitute back into here, either of them. So my equation is x minus 4 squared plus y squared equals 16. So I sub either x at y or y x. So let's do y. So x is y minus 4 squared plus y squared equals 16. Then you can solve for y from here by expand out. So y squared minus ay plus 16 plus y squared equals 16. 16 and 16 go away. Y squared plus y squared, sorry, is 2y squared minus 8y equals 0. Take the 2y out, you get y minus 8 equals 0. Y minus 4 equals 0. So you have y equals 0 or y equals 4. And because y equals 0, x is also 0 because x equals y. So x equals 0 or x equals 4. So you got the point here as 0, 0, xy, or 4, 4. So 2-point intersection. Okay. And the last example here. So here is find the point of contact, which pretty much find the point intersection between this and xy equal 1. So again, the same thing. You can make y as a subject, and then or you make x a subject and then you substitute back in, or you can make y subject from here and substitute back in. Either we do. Okay, maybe this time I do this equation here. So here, from here I can see y here also. So I just move it over so I can make y subject easily. So I have y equal to 2/3, and then you minus the whole thing over here. So minus 1/9 x. Then you substitute in here. So xy equal 1. Now x 0 again, and the y you replace in by this. 2/3 of minus 1/9 x equal 1. So you can, expand out and solve x from here. You get 2x over 3 minus, if you time this over, you get 1/9 x squared equal 1, like that. All right, then you can solve for x. But before solve for x, see the fraction here? We're going to make it nicer. We're going to make them the same denominator. So 3 and that's 9, so we times 3 here, times 3 here. We get 6x minus x squared, so we can write them together like that, over 3 times 3, 9 equal x squared. Sorry, equal 1. Then to get rid of the 9, we multiply the 9 over to get rid of the fraction. So we get 6x minus x squared equal 9, like that. Then we make one side equal 0. We have 0 equal. The negative x squared, when you bring over, you make it positive, and it's better to be positive. 6x finished over minus 6x plus 9, like that. Then solve it. So ham together is 9 added 6, which is negative 3 and negative 3. So x minus 3, x minus 3. And you have x minus 3 squared, which means the solution is x equal 3. And when you get x equal 3, you can find y by substitute back in x, y equal 1. So x times y equal 1, x is 3, 3y equal 1, y will be 1/3. So the solution is 3 and